Good evening, sir.
Good evening. Okay, let me start the class. Okay.
Yes, sir.
So, first of all, uh, go for the question answer session from IS Code
Yes, sir.
for 5 or 10 minutes. Okay. So,
Yes.
what is the what should be the pH value of water for concreting? Please, anyone tell me.
Not less than 6.
Less than 6.
Yes, not
Not
less
less
than
than
6. Okay.
not less than
Yes.
6.
Yes.
Not less than 6, sir. Not
What
less than
should be the problem if it is less than 6? Why it is not less than 6? Could anyone tell me? Why it is not less than 6?
Initial setting time is 30 minutes.
So,
Harmful salts.
no, actually, the fundamental things of physics. That is, if it is less than 6, that means it is acidic. Okay. So,
Okay, sir.
due to the acidic property of the water, it may create the corrosion of reinforcement. Okay. So that's why it would be better if you don't use the water which is acidic. Okay, you have to avoid this character, acid
Okay,
character
sir.
of the.
That's it.
Okay. Okay. Now you tell me what should be the permissible limit of inorganic matter in water. Mowgli, tell me. What should be the inorganic matter in water according to S456? Hello?
Sir. Yes, sir. I'm here.
No. Mowgli, tell me.
Sir? Sir, 3000 mg per liter.
3000 mg per liter. Okay. Ronit, you tell me organic matter. What should be the organic amount of organic matter? Permissible limit. Ronit. Amartya, you tell me. What should be the organic matter? Limit of organic matter. Amartya. Hello. I think they are not present.
Sir, I tell, sir.
Okay. Vivek Roy. Vivek Roy.
Yes, sir.
What should be the permissible limit of organic matter?
I cannot remember in this time.
Okay. Anish Kumar. Anish, unmute yourself. Hello, Anish. Shaurabh Roy. Shaurabh.
Yes, sir. Yes, sir. Sir, 200 mg per liter.
Oh,
Organic.
200 mg per liter. Now you tell me what is the flexural strength of concrete? What is the formula according to IS 456? Saurabh, tell me what should be the flexural strength of concrete?
Sir, 0.7 root over FCK.
You have to complete the answer, okay?
Sir, unit.
Yes.
Newton per mm square.
Yes. This is the actual answer. The flexural strength should be 0.7 root over FCK Newton per millimeter square. Very good. Now Bhaskar, you tell me the modulus of elasticity of concrete. Modulus of elasticity of concrete.
5000 root over FCK.
5000 root
Sir,
over FCK.
5000 root over FCK Newton per mm.
Okay. 5000 root over FCK. Is it short term modulus of elasticity or long term?
Sir, this is short. This is 1 plus theta. Sir, this is short term elasticity.
Yes, this is short term modulus of elasticity, and this is also static modulus of elasticity. Okay. Abir, you tell me what is the value of total shrinkage strain. Unmute yourself, Abir, and tell me what is the total value of total shrinkage strain of concrete. Value of shrinkage strain of concrete. Tell me, Abir. Value of shrinkage strain in concrete. Anamul, can you tell me total shrinkage strain of concrete? Arindam Mondol. Arindam. Hello. Arindam.
0.0003.
0.0003. Okay. Okay, Ronit, tell me, Arindam, tell me the range of high strength concrete according to IS 456. Range of high strength concrete according to IS 456. Tell me. A range of high strength concrete. Animesh?
Sir, I can tell.
Okay. Tell me.
Yes, sir.
Vivek, tell me. Vivek, tell me.
Sir, 5 high strength gate concrete.
No. What is the range of high strength concrete? What is the range? Range means this
Sir,
from this point to this point. Like
Sir,
that.
M60 to M80.
M?
Sir, M60 to M80.
No, actually in your WhatsApp
M60
group,
to M80.
in your WhatsApp group, I have already provided the IS 456 including all amendment. Okay, so in the new amendment, there is some change, and you have to remember the current data, not the previous data. Okay, so whatever you told, this is actually the previous data, not current. Recently it is changed. Okay?
Sir, due to IS 456 2000. That is correct.
No, IS 456 2000, there is a 5 amendment. In the amendment, they have corrected the data, and you have to remember the newly published data, not the old one. Okay. Okay, Simo, tell me what is the range of high strength concrete? Hello.
স্যার পুরোটাই আমি জানি, আমি নতুনটা দেখিনি।
I have already provided in your WhatsApp group.
মানে পুরোটাই আমাদের কাছে আছে, তো আপনি যেটা দিয়েছেন ওটা আমি ঠিক নোটিস করিনি, তো পুরোটাই আছে।
So you have to update yourself, na? Okay. Anyone can tell me what is the range? Anyone?
Sir, 65 to 100.
Yes, M65. You should say M65 to M100. Okay, so M65 to M100. And for standard concrete,
Sir, M25 to M60.
M25 to M60. Okay, Bhaskar, you tell me what is the creep coefficient at the age of loading of 7 days?
7 days, sir, 2.2.
Okay, 7 days is 2.2. Ronit, you tell me creep coefficient at age of 28 days of loading.
Sir, can you please?
Yeah, sir, 1.6.
Oh. Ronit, hello. Ronit.
Yes, sir. Sir, কথা কেটে কেটে
Okay.
Sir, 1.6.
Okay. Okay. Now you just read page 17 and 18 also. Okay. Now
Okay, sir.
your homework is from 13 to 18 total. Okay.
Okay, sir. Okay.
13 to 18. Please keep in mind 13 to 18. Okay.
Hmm.
You have to
13 to 18 page. Okay. Yes.
13 to 18. Okay. Okay. Now let me start the limited method of design. So in
Okay.
limited method, you have already know the stress strain curve of concrete. Please mute yourself. Please mute yourself. Okay. Now the stress strain curve of concrete is like that. This is the curve portion, and you have another straight portion. And could anyone tell me
Sir.
yes. Tell me.
Sir, scheme, sir.
Hello.
Sir, scheme, sir. Hello.
Tell me please again.
স্যার এই স্ক্রিনটা দেখতে পাচ্ছি না তো।
Sir, scheme, sir.
Oh, sorry.
No, 7 is sir, correct.
Sorry.
The scheme, sir.
Now I think you can watch my screen.
Yes, sir.
Okay.
Yes, sir. Yes.
Now you know that the stress strain curve of concrete is like that. So there is a parabolic portion, and after that there is a straight line. Okay. And there is two important value of strain. One value is 0.002. Why it is important? I will show you later. And another point strain value is 0.0035. Okay. And this maximum stress value we denote it as FCK. So what should be the FCK value? If you say that our concrete is ordinary concrete, then the FCK value is 10 or 15 or 20. Okay. If you say our concrete is standard concrete, then the FCK value will be 25 or 30 or 35 or 40 or 45, like that, up to 60. Okay. Now if you say our concrete is high strength concrete, then the value of FCK will be 65 to 100. Okay. So this FCK value will vary from 10 to 100. as per IS 456. Okay, now the concrete is made in the field. It is not produced in a laboratory. Okay, so generally concrete is made in the field now by the labor. Okay, and laborer, I should say non-skilled labor, so they don't have any idea about setting time of cement. They don't have any idea about specific gravity of all those material. They don't know what is the value of pH value of water. They don't know actually. Okay, so that's why they create the concrete with some negligence. Okay, now another important part is when we are going to construct. You see, the concrete is, what is concrete? First of all, you tell me, on anyone, what is concrete? What is concrete? Please tell me. Yes, tell me, what is concrete? What is concrete?
Sir, concrete is a mix of binding materials and fine aggregate and aggregate.
Okay, now if I mixed 1 kg of cement and 10 kg of sand and 100 kg of aggregate with 2 liter of water, then is it concrete?
Sir, this is
No,
concrete
sir.
but not
No.
economical
No,
because of
no, actually this is
No,
not
sir.
concrete, because we have to mix all the material with a certain proportion. Okay, to get the strength. Okay, our required strength. According to our required strength, we have to mix the all the material, aggregate, sand, water, cement, all, or admixture, all those material. Okay, so concrete is the mixture of all those material with specific ratio. Okay, now in concrete, you know that there is some aggregate like that. So all those aggregate are like unique shape. Okay, no one the shape of one aggregate will not match shape with another aggregate. Okay, so there is some sand also. Okay, and another important part is cement paste. There is some cement paste. Okay, now the specific gravity of sand is not equal to specific gravity of cement, and obviously it will not equal to specific gravity of aggregate. All those materials, specific gravity of all those material are different. Okay, so that's why suppose you are constructing a column. Okay, in this column you pouring the concrete from the top. Okay, now what will happen, one time you can see the heaviest material, aggregate, heaviest material, that is means the aggregate will be placed at the bottom with high density. Okay, and the lightest material, that is water, will store at the top. Okay, so that means if you take one part from this one sample from this part, and if you take one sample from this part, so strength will vary, although it is casted at with same time with same concrete. Okay, now there is another problem like that. Suppose you are constructing a beam. Suppose this is the beam, width of the beam, this is the plan of the beam, and this distance, that means the width, is not actually constant throughout the length. Okay, that means the volume of concrete here and volume of concrete here are not same. Okay, so though this is a monolithically casting beam, but the strength will also different. Okay, now for those problem, we assume that the strength of material is actually not FCK. Strength of material, please keep in mind, strength of material is actually not FCK, it is less than FCK value. Okay, so what should be the assumed value of the concrete? We are considering this line, this is the curve we are considering. Okay, now this value is FCK and this value is multiplied by some constant 0.67 FCK. And what is this constant? This constant is coming from the size and shape factor. Okay, size of aggregate is not properly placed at every position. So in this position, size of aggregate and alignment of aggregate will differ from this position. Okay, so because the size of aggregate is not actually, this is not same for if you take 1,000 number of stone chips, so that means you have 1,000 number of shape also. Okay, so this constant 0.67 is coming from size and shape factor, and sometime you can find that this 1.67, if I write 1 by 1.5, okay, then it will be 1 minute. It will be equal to 0.67. Okay, but please keep in mind our 0.67 is not coming from this. Okay, it is actually 0.67. It is not coming from 1 by 1.5. Okay, why I am telling this, you will understand within few minutes. So our stress strain curve, assumed stress strain curve considering the size and shape factor, is lower than FCK because the constant value 0.67 is less than 1. That's why if we multiply this 0.67 with FCK, then obviously it will be less than FCK. Okay, now I stop here. There is another curve. Okay, and I will say after completing the stress strain curve of steel. Okay. Now, what is the difference between the stress strain curve of mild steel and stress strain curve of HOSD bar? I have told you already. Please, anyone tell me what is the difference between stress strain curve of mild steel and stress strain curve of HOSD bar? Please tell me, anyone. Unmute yourself and tell me.
স্যার ডাক্টিলিটি পারপাসের দিকে থেকে দেখতে পারি।
Yes, ductility purpose, but it is not actually. I don't want this answer actually. I have already told you. What is the difference between mild steel and HOSD bar? You can see the mild steel, the stress strain curve of mild steel like that. But the stress strain curve of high strength reformed bar is like that. Okay, it is like that. That means stress strain in curve of mild steel has a specific yield point. There is a specific yield point. Okay, so if you assume this curve with our simplicity, like you can assume this is like that. Okay, but you cannot assume the stress strain curve of HOSD bar like the mild steel one. You have to assume with this curvature also. So this is the curvature. So this is the difference. You can see the difference between stress strain curve of mild steel and HOSD bar. This is the main difference. Okay, please keep in mind, in stress strain curve of mild steel, it has a specific yield point. Okay, and in HOSD bar it does not deserve any specific yield point. It has a curve portion. Okay, now we denote this value as Fy. Okay, we denote this value, yield stress, that is Fy. Okay, this is actually Fy. Now I have told you that in working stress method we have considered the strength of the material. The strength of the material is very lower than the actual strength. Okay, so for M20 grade concrete we are considering the 7 Newton per millimeter square, very lower than the 20. But in limited method we are considering the actual value of material, and again I have told you, in working stress method we did not apply any factor of safety for load. We did not apply any factor of safety for load. So when we apply some load on a particular structural element, suppose this is W, and from the lifespan of this, throughout the lifespan of this beam, say 0 to 50 year, this W amount of load will act maximum. Okay, so it will not exceed W. But when we are going to design according to limit state method, we have to consider that this W is actually multiplied by 1.5 if it is a dead load. Okay, or a live load you can see also. I shall show you the load combination, no issue. So generally we have to assume that the coming load is not actually W, it is greater than this, because we are multiplying a constant which is greater than 1. That means if I multiply this constant with W, it is obviously greater than W, isn't it? So it is greater than W. So what we are going to do, we are actually increasing the load. Okay, we are assuming that the coming load will be higher than W. Then, and obviously I know that in the lifespan of the structure it will not exceed W. That means we are ensuring the safety from the load. Okay, we are ensuring the safety from the load. And there is another so this 1.5 is actually safety factor. Okay, this is safety factor. Okay, so now the another part is we are considering the strength of the material. Suppose for concrete suppose this is 20 M20 grade concrete. Okay, now I have told you we are considering the total amount of strength. Now we have to apply the factor of safety on the material. So should I assume the material strain is greater than the actual one or less than the actual one? Should I increase the strength or decrease the strength? Should I consider the strength of the material is increased or decreased? What should I do? For the load, you have seen that we have to increase the load. Okay, by multiplying 1.5, that means this value, this constant is greater than 1. But for material we have to apply the factor of safety which is less than 1. That means we have to divide. Okay, so this factor of safety will decrease the strength of the material. Okay, please keep in mind, for load case the factor of safety will increase the value of the load, and the factor of safety for material will decrease the strength of the material. So this is 1 by 1.5 for concrete and 1 by, could anyone tell me the factor of safety for steel?
1.15, sir.
Yes, 1.15. 1.15 for steel. Sorry. So for steel it is 1.15 and for concrete it is for steel it is 1 by 1.15 and for concrete it is 1 by 1.5. Why we consider different value for steel and concrete? Could anyone tell me? Okay.
What, sir?
Why we consider the value of factor of safety for steel is lower than the factor of safety for concrete? You see, the factor of safety for concrete we are considering the value is 1.5 and for steel it is 1.15, which is less than 1.5, isn't it? So why for steel we have to consider the less value, this value, which is less than the 1.5. What is less?
Sir, because of steel is
Yes. Try.
Because steel is elastic material and
No. Actually, the reason is that
So,
yes,
because steel is manufacturing in factory where the temperature are under control, and
yes.
concrete is manufactured manually where the temperature are not under control.
Yes, not only temperature, you see the concrete is made sometimes by unskilled labor. Okay, so there is various factor is coming which will affect the strength of the concrete. Temperature, water cement ratio, okay, the amount of quantity of cement, quantity of aggregate, okay, the properties of aggregate, all those things will come. So we generally we apply the higher amount of safety factor for concrete, okay, and steel is producing in a perfect in a manufacturing industry, okay, with perfect control, okay. That's why the variation of steel is a little bit less, okay. That's why we apply the less amount of factor of safety for steel, that is 1.15, okay, and for concrete it is 1.5, okay. Now go back to the slide of stress strain curve of concrete. Now you see, now we have to apply the strain factor of safety on this second curve, that is 0.67 FCK. If we apply the factor of safety, then this curve will be like this. So this is the curve, and this value is actually 0.67 FCK by 1.5, okay. So this value is 0.67 FCK by 1.5. Now our design curve for concrete. Now our design curve for concrete is this. ওই যে now the design curve, the maximum strength, what should be the maximum strength now for concrete? What should be the
0.67.
Yes, tell me.
It's a 0.67. FCK calculation.
Point 0.67 FCK.
67 FCK.
FCK.
It's a design value
Yes, design strength
by 1.5.
Yes, by 1.5.
1.5.
This is the strength, okay, and
Equals to-
this strength, 1 minute,
Sir,
this-
equals to point.
yes, equals to, hello,
Equals to 0.45 FCK.
0 point equals to
45 FCK.
0.45 FCK, okay. Now this value is 0.45 FCK. That means the y distance from the origin of the curve, this distance is 0.45 FCK, and this strength will start at the strain value. Please tell me the strain value. 0. I have already told you, no? 0.002. 0.002, and it will end at the value 0.0035.
0.0035.
Okay, so this is the stress strain curve of concrete, and for steel, suppose we are considering the mild steel only, like at right now. Okay, so after that I shall show you the stress strain curve for HOSD bar. Okay, so this is actually straight line, this is another straight line, and this value is Fy by 1.15. Okay, so this value is Fy by 1.15, and we can write it as, tell me.
Yes, sir.
We can write it as
45 FCK.
not 45, 1 by 1.15. This is 0.87 Fy. Okay, this is 0.87 Fy. So you can remember, I should say you have to remember this value, 0.87 Fy for steel, and 0.45 FCK for concrete. Okay, you have to remember. Now for concrete, you see that there is two strain value, 0.002 and 0.0035. Okay, now what should be the value of strain for steel? What should be the value of strain for steel? The strain is at this point is 0.002. You got my point? At this position, this is 0.002. And is there any other strain value like concrete? No, because actually this line is very long. Okay, this line is very long because this is ductile material. Okay, so due to the ductility property of this steel, this line is very long, and you can see there is no other limiting strain value for steel. Okay, now I think you can understand the stress strain curve of concrete and steel. I think you can understand. If you have any problem, any doubt, please tell me right now. Do you have any problem, any doubt regarding this stress strain curve of concrete and steel? No doubt? Okay.
No problem.
Okay. One thing you please remember that the FCK value is the range, I should say the range of FCK value should be greater than or you can say this is 10 to 100 according to IS 456 ordinary to high strength concrete. This is 10 to 100, but in case of FY this value is number one is 250, that is mild steel. Okay, and number two is 415, 500. There is another strength value of steel also, like 550, 600 also, but IS code, all those please keep in mind, all those are falling under the HYSD bar. HYSD bar. Okay, so only 250 is mild steel and 415, 500, 550, 600 are HYSD bar. Okay, now only 415 and 500 now, still now only 415 and 500 is our consideration according to IS 456. According to IS 456 there is only 2 HYSD bar, 415 and 500, and you can use the mild steel 250. Okay, so according to IS 456 you can use only three type of reinforcement. One is mild steel bar 250, another is 415 HYSD bar and 500 HYSD bar. Okay, now at the last position of this class I want to tell you new things, that is when we are considering this stress strain curve of concrete, we are considering the strain value. I have already told you we are considering the strain value in limited method. Okay, now what does it mean? It means that when the strain value of concrete at topmost fiber of the beam will exceed 0.0035, it will fail, it will collapse. We have to consider that it will collapse. But for the case of steel there is some difference. There is no upper limit like 0.0035. Okay, so the limitation is like that. You have to ensure that, please keep in mind, please listen me carefully, you have to ensure that the strain of the steel, okay, the strain of the steel should be greater than 0.002. That means the strain should be greater than 0.002. It should be greater than this value. That means the strain of the concrete will should be fall in this range. Okay, suppose you are designing a structural element where the strain of the concrete is less than 0.002. okay, suppose it is 0.018, so it is not acceptable. Okay, it should be 0.002 or greater than 0.002. okay, so I think you can understand the limiting strain, difference of limiting strain of concrete and steel. In concrete, we have to remember that the strain should be less than 0.0035. okay, the strain should be less than 0.0035, and in case of steel it should be greater than 0.002 or equal to. okay, so we shall discuss in details about the limiting value, and we shall learn about the stress diagram, strain diagram in limit state method in the next class. I shall stop today's class here, and you tell me if you have any doubt. You can tell me.